Our immune system has several key components, and the most important ones are probably not what you're going to expect. The first component is the innate immunity. The immune system is like the military of our body. It has several lines of defense, and the first line of defense is the mechanical barriers. Think of our immune system as an ancient medieval castle. The tall walls of the castle provide a mechanical barrier, not letting enemies through. Similarly, we have our skin, mucous membranes of the respiratory and GI tract, which are watertight without letting any microbes through. Then you have the moat, filled with toxic chemicals. Anyone who dares to pass through will dissolve into nothingness. Our body also has a similar chemical barrier, which is the secretions made by our gastric mucosa, the sebaceous glands, our sweat glands, and all those chemicals that are secreted into the surfaces of our mucosal membranes. They have antimicrobial properties, contains antimicrobial agents like peptides, fatty acids, and enzymes such as lysozyme, capable of neutralizing or destroying antigen. The castle is fully stocked with resources and prepared for a siege. The attackers outside will have to fight for the little food they have left. So even if there are fighters who are capable of passing through all these chemical and mechanical barriers, they'd still have to fight with each other to get some nutrition, get some energy and other resources. Our body also has a similar line of defense. Our body has more microbial cells than the number of cells in our entire body. So all these microbes will have to fight with each other to survive on the outside of these mucosal membranes and the skin. These are called commensals. While they're outside, they're actually harmless. They can't do anything because they're too busy fighting for the scraps. But if somehow they get into our body, they can cause real harm. But for now, they're outside, so there's nothing to worry about. Then we have the white knights, the white blood cells, which are patrolling the perimeter, trying to find if there are any invaders from the outside and destroy if they find any. It's like the cells of our innate immunity that can recognize foreign cells and attack them. Moving on with our castle analogy, let's talk about the differences between innate and adaptive immunity. The innate immunity is there from birth, like the walls of the castle are there since the time the castle was built. So similarly, the innate immunity was there from the time since you were born. But the adaptive immunity is like the intelligence, it's like the CIA of the castle. It's like the intelligence of our body. It can identify specific antigens and attack specifically. So at the beginning, when the castle was built, the intelligence division was not so efficient. So similarly, the adaptive immunity builds up its defense with time. And this intelligence division, they keep a database of all the criminals that they have come across. They have memory. And similarly, the adaptive immunity also has a memory. Once they've come across a specific type of antigen, they will keep that in their memory, and they will know exactly how to attack that when it comes across that antigen on the second time. The innate immunity, which consists of these walls and moat and the border patrol, they don't exactly keep records of people that they attack or they come across. So they just know whether you're from the inside or outside. That's all the difference that they can make. But something about the adaptive immunity is it has a tendency to attack the body's own cells. So think of it like a scenario where the CIA mistakes one of its own citizens as a terrorist and interrogates them and attacks them thinking that they're a terrorist, but actually citizen of their own castle, I guess. And that is like one downside of the adaptive immunity. The cells that are involved in each of these immune systems. The innate immunity involves cells like macrophages, granulocytes, and natural killer cells. These are non-specific cells. They just attack anybody from outside that they come across. These cells recognize pathogens broadly through something called pattern recognition receptors. Whereas the adaptive immune system has B cells and T cells that can recognize specific antigens and attack them specifically. The adaptive immune system can again be divided into two: humoral immunity and the cell-mediated immunity. In the humoral immunity, the defense is given by antibodies. In the cell-mediated immunity, the defense is given by, obviously, immune cells. But that doesn't mean that the humoral immunity doesn't involve cells or that the cell-mediated immunity doesn't involve antibodies. There's always crossover with all these systems. They are all interconnected with each other. The humoral immunity is mediated by B cells, whereas the cell-mediated immunity mainly involves antigen-specific CD4 and CD8 T cells. And non-specific cells like macrophages and neutrophils and NK cells also play a role in the cell-mediated immunity. The B cell receptors can identify unprocessed antigens. They have membrane-bound antibodies to detect those antigens, but T cells, they cannot recognize unprocessed antigens. They have to be processed and presented to them by another antigen presenting cell. And finally, there's the complement system that plays a role in both the innate and adaptive immunity. I couldn't find a way to incorporate this into the car-cell analogy, but basically it's a bunch of proteins in the bloodstream called complement protein. These get activated one after the other. One activates the other and so on, like a cascade. And these play a role in activating certain cells to provoke an immune response. And also they form something called the 𝗦ci, the membrane attack complex, which can perforate the cell membrane of attacking cells, microbes, and then destroy them. And all of these separate components of immunity that we discussed today will be discussed separately in their own topics in a separate video. And if you don't want to wait for the videos to come out, you can always go ahead and check out our web articles. I have made an entire web article series on immunology. And also if you want to have like a sort of a note you want to refer to while you're going through these videos, go ahead and check those out at 𝗦cznie𝗰𝗶𝗹𝘀. And as always, if you like this video, make sure to leave a thumbs up. If you want to catch more videos like this in the future, make sure to subscribe to the channel and click the notification button.